Okay, in this lecture we will see a problem solving on DC shunt motor. So let us read the problem first. It is given that a 240 volt DC shunt motor runs on no load at 800 rpm with no extra resistance in the field or armature circuit. The armature current being 2 amperes. So this 2 amperes is when the no load condition is there and the motor is rotating at 800 rpm, and they are asking us to calculate the resistance required in series with the shunt winding so that the armature may run at 950 rpm when taking a line current of 30 amperes. So for the other case of rotation of the speed, that is at 950 rpm, they have given you the line current and they are asking you to determine the extra resistance that is required to connect in series with the shunt winding. Okay, and that is the question. And they have also given that shunt winding resistance is 160 ohms, that is RSH, and armature resistance is 0.4 ohms. And they mentioned that assume the flux is proportional to field current, not assume, assure. So that means they are saying that flux is proportional to field current. So it is a known fact. Okay, for that particular question, first you need to draw the circuit diagram. Since it is DC shunt motor, we all know that the field winding is in shunt with the armature, and armature will be having an armature resistance of Ra, and it is going to take current of Ia with line current as I and shunt field winding current as ISH, and RSH is given as 160 ohms, Ra is given as 0.4 ohms, right? Okay, and we have back EMF across the armature, which is EB indicated as given here. Okay, let us first write down the given values. What is the voltage? It is 240 volts supply voltage, because shunt motor takes electrical input. We need to supply a voltage value which is given as 240 volts. And if we consider the speed at first condition as N1, so it is 800 rpm. For that particular speed, the armature current is Ia1, which is given as 2 amperes. And for the other case, the second case, N2 is 950 rpm. And in this particular case, the line current is mentioned as IL is equal to 30 amperes. So this is line current, that means this is nothing but I. You can even consider it as IL or I. Okay. And RSH is 160 ohms, RA is 0.4 ohms. Fine. Now, how can we determine ISH? So it is a simple relation of V and I with respect to RSH. So that is V is equal to ISH 1 into RSH. If we consider in the first case, it is ISH1. So in the first case, that means anyways voltage is 240 volts, RSH is 160 ohms. So you are getting 1.5 amperes. Fine. Now what is EB1 in this particular case? So we all know EB1 equation is this one in terms of voltage and currents through ammeter and resistance of armature. Sorry, it is current through armature. So EB1 is equal to V minus Ia1 Ra. This we can get by applying KVL across that loop. So applied voltage V is equal to the voltage drop IaRa plus the back EMF EB. So if you take EB from that, you will get EB is equal to V minus IaRa. So when you substitute the values, you will get EB1. Right? This is corresponding to the first case armature current, that is 2 amperes, which is given. Okay, next for the second case, let us determine ISH2 first. And what they are saying in the second case, there is some resistance added in series with the shunt winding. That means now the shunt winding total resistance will be RSH plus R. So that is considered here. Right, this is the second case. Let us given it as case 2. And this is case 1 without any extra resistance. Okay, in this case you are having the current in terms of unknown value of resistance R. So for this ISH2, what will be Ia2? So IA2, if you apply nodal analysis here, you will get I is equal to ISH plus IA. So from there you can get IA is equal to I minus ISH. So since it is for case 2, it is IA2 and ISH2, right? And the line current in case 2 is already given, that is 30 amperes. See, it is clearly mentioned that is in case 2 because it is when extra resistance is added. So make a note here, this is case 2 line current. Okay, so we are going to use that 30 amperes here, right? And minus ISH2 in terms of resistor R, unknown resistor, is given here. Right now we need to calculate EB2. What is EB2? It will be V minus IA2 into RJ, right? So it is 240 minus, and this one, whatever is IA2, has to be substituted here. With that you can get EB2 in terms of unknown resistance R. Now the requirement is to determine this unknown resistance, and we all know there is a relationship with respect to speed, back EMF and flux. What is that? EMF, that is back EMF, is directly proportional to flux and speed because EB is equal to pi ZNP by 60A. From that you can get this. Since the flux is proportional to the shunt field winding current, we can directly substitute ISH in place of pi, which is given here. So from this expression we can write that N2 by N1 is equal to EB2 by EB1 into ISH1 by ISH2 because ISH is inversely related. So when you substitute all the determined values here, that is EB1, EB2, ISH1, ISH2, you will get this final equation. Okay, and since this is because EB2 is in terms of R. So when you substitute all the speeds, that is N2 is 950 rpm, N1 is 800 rpm, all those things are given here, right? So and EB2 is unknown, right? So from this we will get a relationship between EB2 and R. Okay, next step is to just simplify these two, right? Since we already have EB2 equation in terms of unknown R, we can use this here as EB2. So when you get two equations which can be equated in terms of R, when you solve them you will get the unknown R, right? So you just cross multiply, you will get unknown resistance R as given here. So if you observe, what is this extra resistance R that has to be added to the series, that has to be added in series with the shunt winding? It is 38.9 ohms, right, which is asked in the question. So the additional resistance required in series with the shunt winding is R is equal to 38.9 ohms. So this is how you need to determine the extra resistance needed. That means as a whole there are two different cases. So in order to get a relationship, we need to know this main formula, how speed, EB and pi are related. If you know this and calculate EB1, pi1 or ISH1 and EB2, pi2 or ISH2, you can get easily the unknown values, right? So this is about the question number 1. We will see the other question in the next lecture. Thank you.